Hi, my name is Muhammad Faizakir and my metric ID is MA18186 and I'm the first presenter for Group 3 and we are doing experiment 3 which is determination of friction losses in pipes. So basically, in this experiment we are going to estimate the head loss that occurs due to the flow of the fluid through pipelines. Overall head loss in a pipe is affected by a number of factors which include the viscosity resistance of fluid, the size of the internal pipe diameter, and the internal roughness of the inner surface of the pipe. We are going to use four types of pipes, which are straight pipe, elbow pipe, bend pipe, and 45-degree angle pipe, with considering Darcy-Weisbach friction factor, the velocity of flow in pipe, diameter of pipe, and length of pipe, we will obtain the result of head loss that due to the friction in those pipes.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atira binti Abu Bakar. My matric ID is MA18188. For experiment 3, friction doses in pipes, I will present about chapter 1, which is introduction. Firstly, we have the background of experiment. This experiment apply continuity equation and Newtonian fluid. Continuity equation is a principal conservation of mass in mathematical expression. In a controlled volume, a single inlet and a single outlet, mass flow rate into is equal to the mass flow rate out. Newtonian fluid is a viscous stresses which is linearly correlated to the local strain state at every point. The problem statement for this experiment, the water supply in residential area is from the main water tank and it has a quite long distance. The pipes need to be in a very efficient state in terms of angle to flow the water in a short time. Thus, we need to calculate the losses, velocity, and pressure in pipes at a certain angle, which is straight, elbow pipe 90 degree, bend pipe 90 degree, and 45 degree. Next, the objectives of this experiment is to determine the major and minor losses with the fluid flow in different piping systems. Next, to evaluate the value of velocity for different diameters of the pipe. And lastly, to apply the concept of Bernoulli's equation in finding the major and minor losses correctly. Last but not least, we have scopes for this experiment. Firstly, we use the fluid friction apparatus and hydraulic bench to control the volume of fluid flow in pipes. Next, we will put the pressure sensor on the desired pipe and using data measurement and data acquisition to calculate the pressure. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afi Izzuddin bin Muhammad Nazri and my metric ID is MA1815. So I will talk about the theory background for this experiment. The friction loss in uniform straight sections of pipe, known as a major loss, is caused by the effects of viscosity, the movement of fluid molecules against each other or against the wall of pipe. Here, it is greatly affected whether the flow is laminar, Reynolds less than 2000 as turbulent Reynolds more than 4000. For high velocities, where the flow is fully turbulent, friction loss is caused by water particles coming into contact with irregularities in the surface of the pipe, and friction factor itself is a function of surface roughness. In general, a pressure decrease between two positions results in the friction factor for the pipe flux. In this case, the friction factor is based on differential pressure measurement values, pipe diameter, distance between the two pressure taps, water density, and bulk speed. Minor head losses can be defined as the energy loss due to fixture such as bends and valve present in the system, while major head losses are defined as losses of energy due to the friction resistance which acts against the flow of the fluid, which can be calculated using the following formula, where the F is the friction factor, L is the pipe length, V is the average velocity of fluid, D is the pipe diameter, and G is the acceleration due to the gravity.
Assalamualaikum everyone, my name is Muhammad Solahuddin bin Mading, metric number MA18242, and for this experiment I will present about chapter 3, that is method and procedure. And for this experiment, the apparatus and material needed is, it consists of 4 elements, that is fluid friction apparatus, hydraulic bench, the third one is the pressure sensor, lastly data measurement and data acquisition for the data collection. And then for the experiment procedure, the experiment will be provided as shown as in the figure. And then the first one, all of the fluid friction apparatus valve will be opened by turning the valve tab to the left. Then when all of the valves been turned on, the power supply and the pump can be switched on. So that control valve is used and adjusted to control the volume of the water. Then the unused valve will be closed for the first experiment, that is track pipe. So that two pressure sensor was plugged into the pipe to measure inside the pipe. And then for the flow rate measurement, the flow rate of the water inside the pipe can be recorded as using the flow rate indicator instrument as shown in the video. And then after we record all of the data for the flow rate, we will repeat the step 5 and step 7 for different type of pipe, that is elbow pipe 90 degree, bend pipe 90 degree, and 45 degree. That is 4 total of type of pipe. And then all of the data will be tabulated and graph head loss against volumetric will be plotted at the result and discussion. That's all from me. Thank you.
Assalamualaikum, my name is Samirul Ashraf. I will continue on results and graphs of the experiment. So the table shown are the data obtained from the experiment, which are the volumetric flow in liter per minute and the measured head loss for different types of pipes, which is the straight pipe, elbow pipe 90 degree, bend pipe 90 degree, and 45 degree. So from the data obtained, we can calculate the velocity of water flow in pipes by using the formula of velocity, which equal to 4q over pi d squared, where the q is the flow rate and the d is the inner diameter of the pipes. Next, we compute the value of Reynolds number by using the formula given, Re equal to rho Vd over mu, where rho is the density of water and v is the velocity that we have calculated earlier, and mu is the viscosity. Next is the coefficient of friction F, calculated by using the Colebrook equation. And finally, when we have obtained the velocity, the Reynolds number, coefficient of friction F, we can finally calculate the head loss by using the formula given, which equal to F LV squared over d2g, where g is the acceleration of gravity and L is the length of pipe. So the table shown are the complete result of the experiment. As you can see here, we have two data sets of head loss, which is the first one is measured head loss, and the second is the calculated head loss. So this is the graphs of the experiment result for different types of pipes. So we want to observe the difference between the measured head loss and the calculated head loss versus volumetric flow. So for the straight pipe, the calculated head loss, which is the red line, are increasing proportionally with the volumetric flow, while the measured head loss, the blue line, as you can see, there is not much of an increment of the head loss as the volumetric flow increase. And for the 90-degree elbow pipe, the calculated head loss increase proportionally with the volumetric flow, while the measured head loss is increasing gradually as the volumetric flow increase. For the 90-degree bend pipe, the measured head loss increase gradually, except for the small scattered plot at the end, and same goes to the 45-degree pipe. So I think that is all for the results and graphs of this experiment. Thank you.
Assalamualaikum. I am Muhammad Nusufian Besude. Now I will continue for the last part of the presentation, which is the conclusion of the experiment. The objective of the experiment are achieved where we could explain the mechanics of friction phenomena in pipes. The head loss is a measure of reduction in the total head of the fluid. Besides, we also understood and could apply the basic knowledge of the major losses in straight pipe. The major losses in straight pipes, which is associated with frictional energy loss per line of pipe, depends on the flow velocity, pipe length, and the diameter of the pipe. The friction losses are inversely proportional to the Reynolds number. If the length of the pipe decreases, then the head losses will be decreased. If the higher the velocity of the fluid, the higher the friction losses. The increase of diameter of the pipes will decrease the friction losses. From the experiment, we saw that the measure and calculate data has such a small difference in result, and it is because of the systematic error. First, instrumental error, where it's poorly calibrated instrument, and the second is observation error, parallel in reading the result. So, I think that's all from our group. Thanks for listening to our presentation. Thank you.